Hello there, creators. I hope that you guys are good and are doing your best to make sure that you are preparing for your physical science paper one on Friday, right? So let us quickly just do a recap on electric circuits, right? So I'll just start from your simplest and basic stuff, right? So just before that, guys, please make sure that you subscribe, you like, and you share, right, with other people as well, so that they might be able to grasp and also learn as much as you are learning, right? So let us start with your basic stuff, right? So your basic stuff would be a simple series circuit, right? So that would be a simple series circuit and your parallel circuit, right? So I won't be dealing with the diagrams, but I just want us to see in terms of how do you get your voltage, how do you get your resistance and everything, right? So we have three components in each, right? So we're gonna have I, we're gonna have R, and we're gonna have V, which is your potential difference, right? We're gonna have I here as well. We're gonna have R. We're gonna have V as well, right? So, right, how is the current in a series circuit? So we would know that when we are dealing with a series circuit, the current will be equal throughout. So I1 will be equals to I2, and which will be equals to I3. Now, depending on how many ammeters you've been put, they've been put there right there on the circuit, right? Then that will mean that is the opposite for your parallel circuit. So that would mean that for you to be able to get your I here, if you want your I total, right? You'd say I total is equals to I1 plus I2 plus I3. So you'd see that in a parallel circuit, the current will now divide, right? So that is where it gets its term of being a current divider, right? That is the parallel circuit, right? So now let us check, how do you calculate the resistance in your series circuit? So the resistance in your series circuit, the way you calculate it would be R total would be equals to R1 plus R2 plus R3. Right. So that will depend on the number of resistors that have been given to you. Right. And how would you calculate your parallel circuit in your resistance in your parallel circuit? So that would be now 1 over R parallel will be equals to 1 over resistor 1 plus 1 over resistor 2, right, and so on. So now that would also be dependent on what? The number of resistors that you've been given, right? Okay, so here you see that you have been given R1 over R parallel. So if you want the R parallel, it will mean that now you'd have to do an inverse of this here. You swap them up so you get your RP. So we'll do a separate video on how to answer questions and how to calculate your resistance, right? Okay, so now let us go on to check our voltage. How do we calculate our voltage in a series circuit? So it will be easier to remember the voltage first in a parallel circuit, because we know that the voltage in a parallel circuit is actually equal. So that will mean that V1 would be equals to V2, and which would be equals to V3. Now, depending on your voltmeters, on how many are they, right? So that is very important to note, that in a parallel circuit, your voltage will divide, right? So now let us go on to your series circuit. So what would that mean for a series circuit? It will mean that in a series circuit, we're gonna have V total being equals to V1 plus V2 plus V3, and that's where the series circuit gets its name of being a potential difference divider, or being a voltage divider, because there your voltage gets divided, right? Okay, so now let us get into the grade 12 stuff now that we do, right? So what are the other things that we need to know in grade 12 in terms of your electric circuits? So what you have to know, it will have to be your Ohm's law, right? So you need to know your Ohm's law definition as per the examination guideline. So what does Ohm's law say according to your examination guideline? So that is actually from your formula of R is equals to V over I, right? So Ohm's law says that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So what you must remember there is that your temperature must be constant, right? So don't forget that, right? So that is your Ohm's law definition, and just make sure that you know it by head and going on to write on Friday, right? So what else now would you need to know in terms of Ohm's law? So now you need to know that in Ohm's law, we'll be dealing with ohmic conductors. So that I'll say is Roman figure 1. So we'll be dealing with ohmic conductors, right? And we'll be dealing with non-ohmic conductors, right? So what would be the difference? So you'll be asked, or you are asked now to know this in grade 12 that, okay, ohmic conductors, what are now ohmic conductors? So simply ohmic conductors are those conductors that obey Ohm's law. So it will mean that they follow the definition of Ohm's law. Then what about non-ohmic conductors? Now simply non-ohmic conductors would be conductors that do not obey Ohm's law. So that would mean it's the different case in terms of your ohmic conductors, right? Okay, let us continue on to check what else do you need to know for your electric circuits, right? So you need to know your power and energy, right? So okay, so from there we know that power is equals to the work done over time, right? So from there also you need to know what the definition of power is, which is the rate at which work is done. So it is much easier to remember your definitions when you use your formulas. So you can see here that here there's work over change in time. So that is why they're saying that power is the rate at which work is done, right? So that would be your time and your work done here, right? So moving on to what else we need to know in your electric circuits. So now you would need to know your internal resistance. So this would have been introduced in your grade 12, your internal resistance, right? So you are given a formula for this, right? So they tell you here that your internal resistance, you can calculate it by using E, which stands for your EMF, would be equals to your V load. So that would be your V load plus your V internal. Right. So we know that, okay, how do we calculate your V here? So V would be equals to IR, right? So you can further expand that to say now EMF would be equals to I times the resistance of the external circuit plus I times the resistance or the internal resistance. So you'd further on go, take out a common factor of I there and say, now this is I into R plus the small r, which is your internal resistance. So in a nutshell, that is what you need to know before going to write your electric circuits. So this is just basic knowledge that you need to have at the back of your mind, or you need to be equipped with even before now going to attempt any question on electric circuits. So join us later on when we'll be dealing with questions on electric circuits and how to approach them. So I hope that you find this useful and you continue to share it with others.